Okay, so this is our first video, and this is the lab sheet. So this is in content for you to fill out. You don't need to print it, you can just download it. It is in Word. Fill it out on the computer and then submit it into the assignment section when you're finished with it. So this is due today. This is a daily assignment. Every day you'll have a different sheet and possibly a video, possibly an electude module, depending on the day of the week it is. So what we're doing today is building a simple series circuit. As you can see here, we have a light board, we have a meter, whiteboard I'm going to write some stuff down on. This is our lab 1, so we'll write that up here. And this is circuit 1. Okay, so we're going to need to find out our source voltage. We can't do calculations without knowing our source voltage, and our first circuit has these two lamps in it, so we're going to go R1. We need to find out the resistance of each one of these lamps. And then we need to calculate our total amperage. And then we need to measure our voltage drop across each lamp. Okay, so first thing we're going to do, we're going to measure source voltage. Now I have our light board powered up by a car battery I have over here to the side. So we're going to take our meter, have it on our 20 volt DC scale, and I am simply going to, now you can see I have power coming into one side of my fuse. I'm going to go to the other side of my fuse and I'm going to check for power. So we have 13.02 volts. Right, and I'm just going to leave that at 13 volts. I'm just going to round it to 13 even. So we have 13 volts in our battery right now to use in this circuit. Okay, so the next thing I need to do before I connect anything up is measure the resistance of my two resistors. So I'm just simply going to go across them, and we're going to measure the resistance. So R1, we have 7.8 ohms. And for R2, we have 8.2 ohms. Okay, so we have, even though these two lamps are the same, we have a different, slightly different resistance between them. So we can never assume just because the lamp's the same, the resistance is going to be the same. Or just because a component is the same as another component, there's always going to be a slight variation. They're not always going to be the same. So we never assume, we never guess, we always test. And that's how we're going to be sure that our results are correct and our diagnosis based on those results are correct. Okay, so now I'm going to build this circuit, and it's simply a series circuit. So we're going to go from our fuse right into our switch, and then we'll go from our switch up to R1. Okay, so you'll notice at the bottom of the light board there is a bus bar on both the positive and negative side. When we build our parallel and combination circuits, we will use this, but for a simple series circuit, we don't need to. So I'm going to just go from lamp to lamp. This is a series circuit, so we go through one lamp and then through the other. And then our ground, I'm going to go from R2, and I'm going to go down over here. And now I'm just going to use this bus bar for ground. It just makes it that much simpler. Get our wire up out of the way here. All right. So let's see if our circuit works. It does. We can see that our lights are coming on. So now we need to take our other measurements here. So because I have the meter set up the way I do right now, the easiest one for me to do first is going to be voltage drop. So that's what we're going to do. So I'm going to put my meter back on the 20 volt scale here. Okay, hopefully everybody can see that. I'll move the lead out of the way. Now I'm going to use back probes. So I have back probes here, these pins, they just fit on. So while we're on the topic of that, the leads I have, as you can see, are double banana plug. Okay, it's very important for us as technicians to be able to work hands-free. We don't want to have to hold these leads onto what we're testing and then have somebody else get in and crank the vehicle. We need to be independent in the shop, right? Everybody's working on their own car, everybody's doing their own thing. So banana plugs on either end allows me to attach different things. I could put an alligator clip and go to ground, and then I can use this to back probe reference wires or signal return wires on sensors. And I can go hook up my meter and go to the driver's seat and crank the engine or turn the key to run, whatever I need to do in that situation, without having to rely on somebody else to come and help me. So, you know, the meter leads that come with meters, this style of lead here with these little pointy probes on the end are not really designed for automotive repair in mind. These are designed to sit at a bench and work on electronic circuits. They're not really designed for what we do. I highly recommend you make yourself some leads like this in varying lengths. They will definitely help you in your diagnostics. Okay, so the first thing that we are going to do, we're doing voltage drop. My circuit is powered. I am going to go in parallel with my load, right? So we go in parallel whenever we do voltage drop, and we can see that R1 is dropping 6.45 volts. So we'll write that on here, VD1, 6.45 volts. Okay. So VD2 should be similar, but we don't assume, we always check. So we are at exactly the same. Okay, 6.45 volts. Now we'll go 4.6. Okay, so we know in our laws of series circuits, if I was to add these two together, of course, I would get my source voltage, 13 volts. So the last thing we need to check here is, of course, amperage. So there's a couple of ways to check amperage, and I'm going to show you both. The second method is the one that is preferred today. The method I'm going to show you first is kind of an older method that we don't really use anymore in the industry, but it's good for you to know it. So if you look at the bottom of my meter, and all meters are similar, right? There's slight variations, but they're all similar. We have our common, which is our ground port all the time. We have our voltage and ohms port, which is what I was just in. And then over to on this side, we have a low amperage and a high amperage port. So I'm always going to go to common with my ground, okay? But I'm going to move my positive lead over to the 20 amp scale. And then I need to turn my dial here down to the 20 amp scale as well. Okay, and then I'm going to put my meter where we can see it. And now what I'm going to do is remove this wire out of my circuit, and I'm going to place the meter in its place. So now my meter is in series with the rest of my circuit, just like my lamps are. So now when I turn my circuit on, my lights are on, and we can see how much amperage this circuit is drawing. And it's 0.17 amps. Okay, so we have 0.17 amps. So that is an intrusive method of amperage testing. And intrusive means we're opening the circuit. We're intruding on the circuit. And like I said, this is a type of testing that really we no longer do in the industry. And the reason is all of our circuits on modern vehicles now have a module that controls them in most cases. And when we open the circuit with a module, we stand the chance of losing memories in that module or presets that the customer has. You know, the modules will actually adapt to customer driving habits in some cases. And if we take power away from them, we can actually affect the way that vehicle drives, and the customer may be back not happy. So we want to avoid doing that. In the rare extreme case, we could actually cause damage to that module or have to have it reflashed, which is another possibility on modern vehicles. So we want to avoid doing this. We want to avoid opening the circuit. So what I'm going to do now is shut this off again and take my meter leads out. And I'm going to put that wire back in to my circuit here. Connect it back up. And I'm going to use a different tool now. What I'm going to use is called an inductive amp clamp. So we'll just hang those out of the way here. So this is the tool that we have here. This is called an inductive amp clamp. So this measures actually in millivolts. And if you look at this, all of these have different scales. I know it's hard to see on the camera. But our bottom scale is 1 millivolts equals 10 milliamps. Our upper scale is 1 millivolts equals 100 milliamps. So whatever I measure on this in millivolts, okay, I'm going to divide by 100. Where do I get that number from? Well, 10 milliamps, we know that there's 1,000 milliamps in 1 amp. That's what milli means, 1,000ths. So if I have 10 milliamps equals 1 millivolt, 1 amp is going to be 1,000 milliamps. So I'm going to have to multiply this by 100 to get my 1 amp. So therefore I'm going to divide whatever my millivolt reading is by 100, and that's going to give me an amperage reading. Okay, now all of them are very similar, but some of them are slightly different. Depends on the manufacturer of the amp clamp. This one happens to be Hantek. This is a BNC connector on this one. Okay, this is actually designed to go with my oscilloscope. However, I have an adapter here that will make it usable with a meter. Or if you have a scope that has banana plugs as opposed to a BNC connector, this will work with that as well. So you'll notice on the one side there's a little tab, that is the ground. So I'm just simply going to put that in the common port. And now I need to set my meter to read in millivolts, because that's what this clamp is designed to measure in. So now I'm simply going to turn on my clamp to the 1 millivolt equals 10 milliamp scale, and you can see I have a number on there. Now I'm going to zero it. So I have a 0 button here on my amp clamp. I'm going to zero my meter, and then I'm going to turn on my circuit again. Alright, and I'm simply going to connect around the wire. Now the best way to do this with these, they're very sensitive, is to simply connect it and then set it down. And it will find its own position. There is a negative sign. The negative sign is there because I have to flip the amp clamp over, but that's fine. We know that. It's not affecting the reading at all. It's like reversing your leads when you take the measurement. The number is going to be the same. It's just going to be with or without the negative sign. So now I'm going to divide that number by 100, and it's going to give me my amperage. So my amperage is going to be 0.15 amps. So it's a little bit different from our measurement through the meter, but it is a very close proximity of it, and I didn't have to open the circuit. Now, I also have this sitting on a metal toolbox, which I am sure is affecting the reading as well. So ideally, you're not going to want this sitting on metal. You can see when I lift it off, it changes slightly. So this is non-intrusive now. We can use this tool for lots of different things. We can use this tool for looking at current ramps with an oscilloscope, which we're going to do in the 243 program. So any of you that are going to finish this course and go into the Auto 243, I will be teaching that as well, and we'll be using this amp clamp to be looking at actual amperage patterns on an oscilloscope. So it's a very, very valuable tool. It's got a lot of great uses. Okay, so that is experiment 1. That concludes experiment 1. So I'm going to shut the camera down, and then we're going to move on to experiment 2.